Good afternoon, everyone. My name is Sumin, one of the BMW support technician in Australia. Today we were going to talk about BMW diesel engine common problems. Before we start, the chat function is open, so please put your question on the chat bar if you have questions during the webinar. After the webinar, I will answer those questions. Thank you again for joining this webinar. All right, let's start. Compared with different brand European car, the BMW diesel engine is not many. We have 4-cylinder and 6-cylinder and 3-cylinder as well. But 3-cylinder, only few models have it. So mainly these 4 engine, but more likely 2 only. N47, that's 4-cylinder diesel. N57, that's a 6-cylinder. But between this 4-cylinder and 6-cylinder, there's not much different. The 6-cylinder only have 2 more extra cylinders, and the engine itself is very similar. So these M engines, that's old one, and this N engine, that's a new one. So we only need to know these 2 different engines. N47 and 57 engines are on this E87 1 series, E90 3 series, and E60 5 series, E83 X3 and E70. And even on same model, after the facelift, there will be different engine, which is the newer one. So exactly same model. Before the facelift, it will be this early model. After the facelift, there will be the newer one. So when I was preparing this webinar, I did research myself based on the support requests coming through from our customer. So I reviewed last 6 months support request, and I figured it out these 3 problems are the common problem. So 1 out of 2 case was related with diesel particulate filter, which is 50%. And 21%, the issue was EGR. And 19% was injector failure. So these 3 problems are the common problems, the most common problems on this early model, 4-cylinder, and the 6-cylinder diesel engine. So let's start from the DPF issue. All right, so the car came into the workshop, and the DPF warning lights on. And what would you do first? I'm getting lots of calls from our customer. Only check the fault, didn't do anything. So what I usually recommend to our customer, before do anything, first see how badly it's blocked. Depend on how badly it's blocked, there will be different way to fix it. First, let's have a look this pressure limit, this 6-cylinder diesel engine. At idle, the maximum pressure you can have is 65 millibar, and 2000 RPM, 150 millibar, 4000 RPM, 250 millibar. So that means if you have more than that, you will see the fault code for the DPF pressure too high, and it will bring up the warning on the dash. But it is more important, you know the reference pressure. For example, car came in and you check the pressure, and that was only 50 millibar at idle. Yes, it's lower than limit, but I will still say we got a problem because it's much higher than normal reading. If the DPF is good condition, what you will see between 10 to 20 millibar and 60 to 70 millibar and 100 to 150 millibar or lower. So that is normal reading on good condition DPF. So I got 3 different cases here. Case number 1, idle 70 millibar, 2000 RPM, 200 millibar, 4000 RPM, 350 millibar. So that means it's higher than limit. So it is blocked, but it's actually not bad. It's a little bit higher than the limit, but not like a doubling up or something. So that's case number 1. Case number 2, at idle, 200 millibar, 2000 RPM, 500 millibar, 4,000 RPM, 600 millibar. So that's actually pretty bad, nearly 4 times higher than the limit. So this is kind of situation of fully blocked DPF. Let's have a look case number 3. At idle, 8,000 millibar, 2,000 RPM, also 8,000 millibar, 4,000 RPM, 8,000 millibar. In this kind of high reading, the problem can be not actual blockage, it's more about electric problem. For example, sensor failure or connector or the wiring. So these 3 different stages, different cases, there are different way we can fix the problem. So let's have a look at the case number 1. All right, so the pressure is just a little bit higher than normal. What we can do on this kind of case, we can use this spray can, the cleaning product, spray into the DPF, wait for half an hour, and go for nice and long driving. So while you're driving, you can do the regeneration. Genuine repair kit is also available. Genuine cleaning kit is available. You can buy it from the BMW, and it works pretty well. So that's case number 1. So a little bit higher than normal. What about this fully blocked situation? In this situation, it's nearly 4 times higher than limit. I would say don't waste your time. Do the regeneration while you're driving. It's not going to work. We need to remove the DPF. We need to send it to the professional cleaning place, or you can clean yourself if you have all this equipment. Same time, you can inspect the DPF for any damage. For example, broken cell or maybe massive hole in the side. That thing happened. All right, so case number 3, which I do see quite often. So the pressure is extremely high, unrealistically high, 8,000 millibar. I don't think the car will be running, the engine will be running at 8,000 millibar at DPF. So in this case, I'm suspecting the sensor is playing up. This is typical 5-volt sensor. The pinout test on this sensor is very simple. Power supply, reference voltage to the pin number 1, which is 5. Pin number 3 is ground. And pin number 2, that's the signal voltage from the sensor back to the control module. This is typical 5 volts pressure sensor. The range will be between 0.5 to 4.5. As you know, if you have lower than 0.5 or if you have higher than 4.5, that's indicating the sensor failure. For example, 0.3, which means sensor is faulty. 4.7, that means the sensor is faulty. Higher voltage means higher pressure. Low voltage means low pressure. I've seen many times our customers are replacing this sensor because at 10 millibar, it already have 2.6 volt. So customer using the manual pressure gauge and checking the pressure, and the pressure is only about 10 millibar. But when you check the voltage at this pin number 2, it's 2.6, which is already in the middle, which is not making sense. That's why people replace this sensor. But that's normal. The reason is this sensor is capable to check the vacuum as well. So it actually starts from minus pressure. That's why 0 bar is kind of in the middle. So 2.6 is normal at 10 millibar. But if you have less than 0.5, higher than 4.5, sensor is faulty. In our theory, you shouldn't need to check the vacuum inside the DPF. That's why the newer version engine, the pressure sensor starts from 0.5. So the newer version at 10 millibar, we are expecting to see around 0.6 or 0.7. All right, so that is the third case. So it depends on, you will see the warning coming on, you will see the fault code with the DPF, but all different situation. It can be a little bit high or fully blocked or unreasonably high, which means the sensor playing up. So let's say we clean the DPF. So we use the chemical or we send it away to get the cleaning properly. So we clean the DPF. Now the pressure reading is back to normal. we need to make sure the engine is capable to doing the regeneration by itself without using the scan tool. Otherwise, if you give the car back to the customer, the car can come back after 3 weeks or after a few months with the same problem. DPF blocked again. So when I see the DPF is keep blocking, there are 3 common problems. One is the engine temperature, which is extremely common. This N47, N57 engine, the thermostat is getting stuck at open. So that means it's cooling down the engine too much. To do the regeneration, the minimum engine temperature is 76 degrees. So it needs to be at least 76 degrees, otherwise it won't do the regeneration. But if you have 78, for example, I will still say we got a problem with the thermostat. If you have 78 when you're driving the car around the town, if you take the car to the highway for the actual regeneration, I'm guarantee it will drop lower than 76. It will be something like a 65 because the car is driving faster and there will be more cold air coming into the engine bay. Good condition, normal thermostat will maintain your engine temperature around 85 degrees or higher. So we want to see 85 engine temperature while you're driving. So that's the most common problem. Keep blocking because the engine is too cold. We need to have a look at the engine temperature. The second common problem is AMS-related fault code. So I'm not talking about any fault code in the engine control module. For example, AMS too low or too high, EGR-related fault, DPF-related fault, auto sensor related fault, those fault code will terminate regeneration procedure. It's more important, we can use the spray cans and things, but it's more important your engine ECU is changing into regeneration mode. That's very important. Your engine ECU need to close the throttle body a little bit to allow less air coming in, and it need to inject more fuel. So those unburned fuel will go into the DPF and it will burn inside. So that's how it clean it. So DPF regeneration control module, changing the mode into the regeneration mode is very important, but this fault code will stop doing that. So there is a small tip for you. When you're doing the regeneration, grab the scan tool with you. Connect the scan tool and have a look at the fault while you're driving. So obviously you need a passenger. So get the passenger to check the fault while you're driving. If there is any fault code coming out while you're driving, keep deleting the fault. So eventually the programming process will go through, the regeneration process will go through. Another thing is, while you're driving with the regeneration, you can have a look at the engine temperature. So if it's lower than 76, then we know the problem is the thermostat. The third reason why the DPF is keep blocking, which is the driving profile, that's something we can't do. If the customer is doing short trip only, it will block the DPF because there is not enough time to do the regeneration and not enough time to warm up to get the operating temperature. So these 3 things we need to make sure before give the car back to customer. Otherwise, the self-regeneration won't be able to carry out. The car will come back for the same problem again. So that was the most common problem, which was related with the diesel particulate filter. The second common problem on this N47 and N57 engine is EGR related fault. But this is very important. EGR itself hardly fail. Always the problem is something else. This is the first generation EGR. As you can see, is fully vacuum controlled EGR. There is no electric. So when I see this EGR, yes, they do get blocked. There's carboning up, but you don't need to replace it. You can give it a good clean. If you suspect this EGR is faulty, there is a way you can test it with a vacuum tester. Supply vacuum to this diaphragm and minus 600 millibar. then the EGR will be fully open position, and hold the vacuum and see whether there is a vacuum leak or not. Simple, isn't it? 600 millibar, make sure the EGR is fully open and hold the vacuum and just make sure it's not leaking. So that case, you can do the function test on this EGR. Again, the EGR itself is very reliable. One problem. So this is the vacuum converter for the EGR. It's located under the intake manifold. We know this intake manifold has got a super common problem with oil leak from the swivel flaps. That's why there's lots of people using the blanking plate to stop the oil leak from the intake manifold. When there is an oil leak from the intake manifold, that oil drops to the electric solenoid, which is controlling the vacuum to the EGR. So that small solenoid sucked with the engine oil and is causing internal short circuit. So that case, this solenoid will continuously supplying vacuum to the EGR, and your EGR will never close. It's always a little bit open. That's why the typical complaint from the customer when there is an issue with the EGR solenoid, no power at low RPM or rough idle. Because at idle or at low RPM, we need the fresh air, not the gas. All right, so 9 out of 10 times when there is an issue with the EGR, the solenoid is playing up rather than the EGR itself. The third common problem is the injector failure. Simply, we can test the injector. Check the resistance between pin number 1 and 2, and the range will be 180 to 184 kilo ohm. You don't need to write this thing down because you got 6 injectors. You can compare each other. The connector, injector connector, unfortunately, you need to remove the intake manifold. Otherwise, you can't get to the connector. What I usually advise to our customer, before you remove the intake manifold, you just order new injector because I'm pretty sure your injector is faulty. But if you want to be 100% sure before order the part, you can check the resistance at the TDE connector. So you don't need to check the resistance directly from the injector. You can check this pin number 1 and 3 at the DME connector. That's including wiring, connect everything. But again, this is very, and always injector number 456. Surprisingly, in the last 6 months, I never seen this injector failure on different body. It was always E70. This is the reason why this fault is common on E70. Can you see this plastic partition is broken? In this case, in the raining day, there will be lots of rainwater goes into the engine bay. And there is 2 pieces of engine cover, front engine cover and the rear engine cover. And there is a bit of gap between front and rear engine cover. See the location of the injector number 5? It's just right there. That's why the most common injector fail is injector number 5. Second common, 6. Third common is 4. In the last 6 months, I never seen injector failure from 1 to 3. It was always one of the injector at the bank 2. So this is very important, fixing this plastic partition. Otherwise, you can have same problem after a few months, even after replace injector, which I've seen a few times. So replace injector, very important, but it's more important replacing this plastic partition. Otherwise, same thing can happen again. All right, so now we are into the new engine, N47 and N57. So 4-cylinder and 6-cylinder, but again, between these 4-cylinder and 6-cylinder, there is not much difference. It's pretty much on every model on BMW now. And I found this model from the timing chain part number. So can you see this X7, which is the very new model? And this G07 has got a B57. So it's not N57, it's B for Bravo 57. The engine is slightly different, but using same timing chain. So I can say, it's pretty much the same engine. Again, from my research, last 6 months, technical support requests, the most common problem is EGR. So it's not the TPF anymore, and EGR is most common problem. And the timing chain, 25%, and the swivel flap failure, which is quite common, but I would say it's more about carboning up problem. TPF issue was also common, but it's not. There's not much thing we can do with it. When I ask those people who are saying, I never want to buy diesel anymore, the most common reason is because of the TPF problem. TPF is keep blocking, and people, suffer for, warning and all that. That's why they don't want to buy diesel engine anymore. So you can see that it's actually improved. That is not somehow this TPF is still get cleaned. Even if there is a problem with the EGR, somehow it still get cleaned on the DPF. All right, so let's talk about these three things: EGR, timing chain, and swivel flap. So swivel flap fault is more about carboning up intake manifold. On the BMW diesel engine, we have 4 different EGR. The first one, which already we had a look, which is fully vacuum control EGR, most reliable. The second EGR and third EGR is in both N47 and N57 engine. Depend on the built year of the engine, you can have this early one or the late one. This early EGR, as you can see, is still vacuum control, but there is a position sensor on the top. So there is electric connector for the position sensor, but actual position of the EGR is the vacuum controller is controlling it. And the third one, which is fully electric EGR, which is extremely common to fail. I think it's not only the BMW problem. All other manufacturers, since they changed the EGR into the full electric control, they're all common to play up. There is a way you can test this EGR. As you can see from the picture, you can remove the plastic cover, and you can operate the EGR with your finger manually. You can push the rod, which means opening. When you let it go, it should comes back by itself. So when you open it manually, let go, and it should close by itself. Quite often, it's getting stuck at open position. According to the BMW instruction, if the EGR is getting stuck at open position, you need to lubricate first. But in the real world, it's not going to work. Even if it's making better, in after a few weeks, the car will come back with the same problem. So we recommend to replace the EGR, especially if this EGR never been replaced last 100,000 Ks. Just a little bit about this. The late model EGR is actually even more common to fail. This EGR was start playing up since this car was new. When I was in the dealership, once a day, every technician was replacing this EGR. It was part of the technical campaign, still is part of the technical campaign. Our timing chain issue is extremely common on this N47 and N57 engine. As you can see, the timing chain is in the back of the engine, and replacing this chain is a bit of a job because you need to remove the transmission, and then you can get to the timing chain. As you can see this picture, the top and bottom chain is broken. Usually they're both breaking. I'm getting lots of calls from our customer and ask me about the quotation. For example, I got a call from one of the New Zealand customers yesterday, and he was asking me about chain is broken and what should I replace? I will give the worst scenario. See the second picture. Top chain was broken, but the middle chain was still turning. So that means your crankshaft is still turning high pressure fuel pump sprocket, and the top chain is getting stuck and is pushing pressure into those chain guide bolts. This bolt with the red circle is super strong. The bolt itself, it will never break. So instead of it breaking the bolts, the chunk of the engine block will come out. It will break the chunk of the engine block. So that means we need a new engine block. So more likely, we need a new engine. So that is the worst scenario. So my answer is always we need to strip the engine first, and we need to have a look. Then we can give the quotation to the customer what we can do if the chain is broken. So it is extremely important replacing the chain before it gets breaking. So let's have a look this video. I made this video myself for this training. All right, let's check the noise. So did you hear the noise? And now I'll remove the local cover and I check the tension on the chain. As you can see, you can move a lot. After replace the chain, it's nice and firm. There is not even 1 millimeter movement. Now we will check the noise after replace the chain. All right, can you see the difference before and after replace the chain? Let's check. Let's watch the video one more time. It sounds more like a vibration. After replace the chain. All right, because it's diesel engine, there is a bit of noise always, but you can see the difference before and after replace chain. It's obviously different. All right, so again, it is very important replace the chain before they snap. Once the chain is snapped, then the repair cost will be, more than double. So how do we know if the chain is broken? There is 3 easy ways to check the broken timing chain. The one, remove the oil filler cap, oil filler neck, and you can see the camshaft through that hole. You can turn the crank with your hand tool, and you can physically see whether the camshaft is turning or not while you're turning the crank, which is only takes about 5 minutes. And the second, you can remove the camshaft sensor. Once you remove the camshaft sensor through the hole, you can physically see the timing chain. So you can see whether the timing chain is there or not. If you can't see the timing chain after you remove the camshaft, obviously it's broken. Third one, when you do the quick test report, you will see the crankshaft reference fault. That means your crankshaft is turning, but your camshaft is not turning. So this is 3 easy ways to check broken timing chain. And again, it's very important. Listen for the noise. If you can hear the timing chain noise, we need to replace the timing chain as soon as possible. And try not to drive the car too much in your workshop because it can break on you. So when you're replacing the timing chain, quite often people ask me whether we have to remove the engine from the car or not. If you have this special tool, this is BMW special tool, you can lift up the engine and move it a little bit forward. E70, this is example of E70 X5. Because the car is 4-wheel drive, we also need to remove the front sump and front diff. To remove the front sump and the front diff, we need to drop the subframe. But again, we got a timing chain in the back, so we also need to remove the transmission. So you can't remove the transmission and subframe together because the engine will be just dangling. So you can move the engine a little bit forward, then without dropping the subframe, you can remove the front diff and front sump. So that means the subframe can stay in the same position and you can remove the transmission, you can remove the sump and the front diff, and you can replace the timing chain. If you don't have this special tool in your workshop, it's gonna a little bit more time consuming, but what you can do, first, drop the subframe, transmission still staying on, drop the subframe, drop the front diff, drop the sump, and put the subframe back on, then remove the transmission. Because we can't remove the transmission, subframe in same time. All right, so the timing chain issue. Now, the carbon buildup. So the fault code will say swivel flap mechanical or swivel flap broken. There's a few fault code can come up, but the problem is carbon buildup at intake manifold. But there is a few more spots having suffer from the carboning up. The first common area is EGR cooler. We know this EGR is very common to fail. So when you're replacing this EGR, I strongly recommend to remove whole unit together. EGR cooler together. And you can give it a good clean with only hot water. You don't need to use any chemical because there is no sludge. It's only dry. It's like a dust. So you don't need to use any chemical. You can use just hot water. You can make it like a brand new. Intake manifold, very common. This is, as you can see, is all sludged. So you need to use the walnut cleaner or special chemical. You can't just use, screwdriver or anything. It's gonna time consuming to clean this intake manifold properly without proper equipment. And the third one is the intake port. Inside the cylinder, intake port is also very common to carboning up. And again, we need to use the special equipment to clean the intake port, which is the walnut cleaner or something else. The most common area having issue with the carboning up, which will also cause the AMS fault, which is the connection between this EGR pipe and the intake manifold. The reason why this area is very common to get blocked up is because the EGR gas is hot and your air just after the intercooler is cold. So hot gas, cold air mixing up together at this point. That's why this area is very common to be blocked up. So we need to remove the intake manifold, give it a good clean, and if you have some special equipment like a walnut cleaner or something, it will be very easy, very good clean. All right, so that was the end of the webinar. I hope you guys enjoyed this webinar, and I can see there is no question on the chat bar, so I believe everybody understood. All right, thank you again for joining this webinar. If you have any question, feel free to give us a call or send an email to us. Thank you so much.